Hello guys, we're going to go ahead and talk about graphing equations, and this is just an overview. It's going to be a pretty quick overview because this is all of the same standards as 8th grade with Common Core. So this is just really brief. What took us 8 weeks in 8th grade to do, it's only going to take us about 2 days in Algebra 1 to do. It should be pretty familiar to you because we've done it so much and we kind of we worked it so many times that it should be ingrained in your mind. Alright? So graphing equations overview, and let's go ahead and get started. And we're going to get started first by stating if things are linear or not linear. These are our rules just to help us remember what a linear equation is. And note, this is the standard form of an equation of a line, but you can also write it as y equals mx plus b, which is the slope-intercept form. So there's multiple ways you can write it. But an equation is linear, and this means if and only if. That's what those two F's mean, if and only if. The first qualification is that x and y are separate terms. And what I mean by that is that x and y cannot be multiplied or divided together. Number two, the variables are not in the denominator. So x and y can never be in the denominator. The third thing that makes something linear is that your exponents of both variables have to be an understood one. And I want you to note this. Understood means kind of invisible because you understand that it's there, so we don't have to notate it because it's understood. So if you look right here, some people make the mistake by saying, well, x and y don't have exponent. That's incorrect. They actually have an understood exponent of 1. So if you see any kind of exponents, then it's not linear. And in a chart, the range and domain increase in a pattern. And there's actually two ways you can look at this. We talked about this last year. Just make sure that in your domain, it's always either increasing or decreasing by the same amount through addition or subtraction. And then your range, make sure that as well. However, what you're technically doing is you're finding the slope between 2 points. And as long as the slope remains constant, it remains the same between multiple points on the graph, that means that it is linear. It makes a straight line. So here's some examples really quick that we talked about in class. And our examples, this was one that is linear because note it has the qualifications. X and y are separate. There's no variables in the denominator. The exponents are both an understood one. And in a chart, the range and domain would increase in a pattern. And I didn't put it in a chart, I just put it as ordered pairs, but you can easily see. Here, my domain, I'm constantly adding 1. And in my range, I'm also constantly adding 1. For it to be linear, though, it doesn't have to do the same thing. Your domain could constantly add 1, and then your range could, let's say, constantly decrease by 3, just as long as it keeps the same pattern. Now, you have to be careful, though, because they might actually, let's say that if I took this ordered pair out and I only showed you 0, 2, 2, 4, and 3, 5, you might think, well, it's not linear. It's not going in pattern. Yes, you just have to fill in the missing terms in order to use this kind of shortcut rule. But the long way would be to say, go ahead and find slope. And by slope, I mean subtract your y's over your x's. And then as long as you do that, you should get the same rate of change between these 2 points as you would these 2 points, as you would these 2 points, as you would even these last 2 points. And that's what makes it linear. Okay, here's another example of linear. These down here, though, they are not linear. The first one is not linear for obvious reasons. If you look at your x, it's constantly going up by 1. I'm not missing any terms, so I can do my shortcut. But here, I'm adding by 3, and then I'm adding not by 3. Because if I was adding 3, it would be 7. So I actually added 5. So since I didn't add the same amount, then it's not linear. Another example is not linear because x and y are multiplied together. Another reason this is not linear because x is on the bottom of the fraction or in the denominator. And the last example that this is not linear is because it is x squared. They have an exponent that is not an understood one. Okay? And once again, linear just means that if I was going to graph it, it would be, ooh, yikes, that doesn't look super straight. But if it, in a perfect world, that would be straight every time I drew a line. But linear is just a straight line like that. Okay? Alright, I'm going to show you why being able to identify if something is linear is important. Because it can also kind of predict what our next points in our line should be. But I want to remind you that there's 3 ways we could graph. We could graph by using a table. We could graph by just finding the x and y intercepts, or by doing slope-intercept form. So either way, you could graph, and you get to choose. But on the worksheet that I created, which we're about to do next, I have y'all practicing each kind of step. All right, so here is the worksheet that I made. And let's go ahead and just look at how to graph the following by making a table with 2 points. Now, the reason why I told you 2 points is because if these are linear, which if you look at our qualifications from the last slides, you can predict what the 3rd point should be just by going in the pattern. But you have to make sure that you're consistently increasing or decreasing by the same amount. Okay, so number 1, if we wanted to do this, all we do in order to make a table, just going to make my XY chart. I'm going to pick an X. I like to pick 0 and 1. And if I go ahead and I plug in 0 for X, I'm going to get out 2. And that makes sense because X is our input, Y is our output. So that is a point, 0, 2. The next thing that I would plug in is 1. So -2/5 times 1 plus 2. And if I put this in my calculator, you would, and you don't have to do a calculator, obviously. You should be able to do this in your head. But you're going to get out 1.6 in decimal form. And I would rather it be decimal form because graphing decimals are much easier than graphing fractions. So we'd go to 1 on our x-axis, and then we're going to go up 1, and then up 0.6. And 0.6 is a little bit above halfway because halfway would be 0.5. Now, we can actually predict what 2 should be without plugging it in there because this is a linear equation. And you would just do this by simply looking at the pattern. Here I decrease by 0.4. So since it's linear, guess what else I'm going to do? Decrease again by 0.4. And I would actually have a 1.2. So at 2, 1.2 would be someone right there. And it should make a straight line. So that's the definition of linear. Okay? All right, for number 2, we're going to go ahead and do the same thing. I'm going to go ahead and make my chart. I'm going to plug in 0 and 1. So when I plug in 0 for x, I get 3 times 0 minus 2y equals 12. 3 times 0 is 0, so I really don't need to even write that. So I have this equation left. Well, if I divide by -2, I'm going to get y as -6. So my first point, I'm going to do it over here, is 0, -6. My second point, I'm going to go ahead and plug in 1 for x. So 3 times 1 minus 2y equals 12. 3 times 1 is 3 minus 2y equals 12. I would subtract 3 from both sides, right? Because I'm just trying to solve for y. And when I do that, I'm going to get 9. And then I would divide by -2. And once again, I have a fraction. But I'm going to go ahead and put it as a decimal, which is -4.5. So 1, go down 4.5, -4.5. Now, since it's linear, you can find your 3rd point by just following the pattern. Now, this pattern might actually be a little bit more difficult to spot just by first glance. So if you wanted to, you could just subtract the 2 ranges. So you could say -6 minus a -4.5. And that's going to give you what it's decreasing by. And it's decreasing by -1.5 every time. And I'm sorry, I said decreasing. I meant increasing. So you're actually increasing 1.5. So since I'm increasing 1.5, my next point at 2 should be -3. So 2, -3. And then you can draw it, make it a straight line. Okay? All right, let's go down to look at how to graph by our next option. And the next option is to graph using the x and y intercepts. And once again, in 8th grade, we learned that in order to find the x-intercepts, you make y equals 0. And then to find the y-intercept, you make x equals 0. Now let's talk real quick about why this makes sense. The x-intercepts are always located on the x-axis, and the y-coordinate for the x-intercepts is always 0. So that's why we say make y equals 0. Same thing for the y-intercept. The y-intercept is always located on the y-axis, And that's where x is always 0 for all of these points. So that's why we say make x equal 0. All right? So the x-intercept, we're going to go ahead and do that one first. So instead of writing y, I'm going to substitute in 0 for it. So I'd have 8x minus 4 times 0 equals 16. Well, anything times 0 becomes 0, and we really don't even have to write it because it just kind of goes away. So 8x equals 16, and then you would just divide by 8. So my x-intercept is 2. Now you can look at this two ways. You can either tell me the x-intercept is 2 and then plot it on the x-axis if you're comfortable with that, or if you'd rather see it as a point, just say what your point was. Here it said x equaled 2, and what did we make y? 0. So it's the point 2, 0, and that's what the point is too. All right, I'm going to do my y-intercept in blue. So for y-intercept, I'm going to go ahead and make x equal 0. So 8 times 0 minus 4y equals 16. Once again, anything times 0 just becomes 0. Then here I'd be left with this, so I could divide by negative 4. So I'm going to get y equals negative 4, and that's my y-intercept. Once again, you could notice, all right, negative 4 for my y-intercept means it's negative 4 on my y-axis. But if you didn't realize that, you could go ahead and make your point. What was your x-coordinate for this problem? Well, I made x 0. And what was your y? Negative 4. So this is also the point 0, negative 4. It's whatever way you're more comfortable graphing it. And just draw a straight line through. Now, let's say, Ms. Fruget, I do not understand x and y intercepts. Well, guess what, friends? You don't have to do x and y intercepts whenever you're working a problem by yourself. You can make a table if you want to, or you can even do slope-intercept form. This is just 3 different ways to work the same kinds of problem. We're just giving you multiple methods. Okay, the last thing that we talked about is my favorite, well, one of my favorite things, which is slope, or rate of change. And for slope, most of us have seen this formula before, which is y2 minus y1 over x2 minus x1. I'm not a huge fan of this formula because I find that people kind of get confused with, well, what's y2 and what's y1? Technically, x1 and y1, because that's your first x and y coordinate. So your second coordinate would be x2 and y2, and then you could plug it in. But our brains are not trained to read from the back to the front. The whole reason why we really have this formula is because in hopes that this ordered pair is going to be larger. That way it would give you like a positive value. It's just like saying instead of subtracting 3 from 4, instead of saying 3 minus 5, you would say 5 minus 3. That's why they have this, which is not even a point on here. It's just an example I gave off the top of my head. But I don't really like this. What I like to say for slope, because it's the difference between your y values over your x values. So I just say subtract your y's over your x's. And that's what we said last year. In fact, we even did hand motions. Your y's over your x's. Okay? So you can remember that. And basically what that means is that you don't have to say negative 2 minus negative 4. You can do the first y coordinate minus the second y coordinate all over the first x coordinate minus the second x coordinate. And it's going to give you the same answer as if you did follow this formula. It's going to simplify to the same thing. Now, if you like this formula, use this formula. But if you think it's easier just to go ahead and identify, let me subtract my y's minus my y's, and then my x minus my x, then use that way. The only thing you cannot do is say, okay, let me do my first minus my second coordinate here, but I'm going to go ahead and do my second coordinate minus my first one on the bottom. No, you cannot. You have to go the same direction on your problem. So let's go ahead and do number 4. So number 4 would be, and I'm going to do it my way, my first y coordinate that I see minus, and just write your minus, then look for your second y coordinate so you don't make a mistake. All over your first x coordinate minus, then look, what is my first x coordinate? Negative 1. Okay, 2 negatives make up plus. Negative 4 plus 2 is a negative 2. Negative 5 plus 1 is a negative 4. And that reduces to 1/2. So my slope right here, guys, 1/2. My rate of change. Beautiful. Okay, let's go ahead and do number 5. Once again, I'm going to subtract my y's over my x's. So I'm going to take my first y that I see minus my second y over my first x that I see minus my second. You're going to get negative 1 over 0. Uh-oh. Some people might think, hey, the slope here is 0, but it's not. It's not. This slope is not 0 because it's not on top. If this was 0 over negative 1, then it'd be 0. But since 0 is under the line, or it's in the denominator, we always say 0 under the line means the slope is undefined, which basically states that you're not going to have a slanted linear line. You're going to have a straight up and down. Ugh, that doesn't really look straight up and down, but you get my drift. You would have a straight up and down line. Okay, so if you get 0 under the line, that means it's undefined. And if 0 is on top, then that's when it's just 0. Okay, and then number 6 is another way that I like to say it. In order to figure out what the rate of change is between these 2 points, we need to go ahead and make them into points. And what do we know that for x-intercepts? Well, we know that y is always 0. What do we know for y-intercepts? We know that x is always 0. And then once again, subtract your y. So 0 minus, then look, negative 2, over 5 minus, then look, 0. The reason why I'm saying then look is because some people would say 0 and then just put minus 2. But you need to remember it's always the difference of this number. So if it's negative 2, it has to still be negative 2 up here. So change this, you're going to get a 2 over 5. And that, my friends, is how you do your rate of change. So let's go ahead and move on to slope-intercept form. Okay, to do our slope-intercept form, you have to remember the formula y equals mx plus b. M is where we jump. And in fact, last year we jumped in our class. Like I would put a slope on the boards and my students would jump to that spot on the floor. And B is where we start on the y-axis. Okay, so this is where we start on the y-axis because it's our y-intercept. And that's why it's slope-intercept form. Ooh, hard, huh? Not really. And M is where you jump because that's your slope. Now, another thing that I say for people is that if you have a positive slope, you're going to go up and right. And I say because positive people are up-righteous. If you have a negative slope, I say negative people are downright rude. They're just nasty. So negative is downright. Positive is upright. Now some people say, but Miss Frugier, what about my lefts? Where do my lefts come in? Do not worry about your lefts for right now. As long as you go upright for your positive, then you can figure out, well, which way would I need to go directionally wise in order to continue a positive slope. Then figure out your lefts. And I'm going to show you that in an example. But for right now, just remember positive is uprighteous, negative is downright rude. Okay, so let's go ahead and look at number 7. So this is easy. This is where I start. So I'm going to start at negative 2. And there's an understood negative 1, okay? And in fact, my slope, it's not just negative 1, it's a fraction, negative 1 over 1. So since that's a negative slope, we say negative people are down, right, rude. So I'm going to go down 1 from where I started, and then to the right 1. And you can continue that all the way down 1, right 1. Now this is what I meant by the lefts. Obviously, in order to keep this a linear line, I would have to go up and then to the left. Up and then to the left. So it's not really necessary that you remember up and left is also negative. As long as you can remember downright rude, then you should be able to figure out up and left once you graph this. Okay, let's look at number 8. And number 8, I'm going to start at 1 on my y-axis, because that's my y-intercept, and I'm going to jump negative 3 over 4. Now, since it's negative, that means it's down, right, rude. So down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. You could do it again if you wanted, but we're kind of running out of room. Now, obviously, in order to keep it going into a line, what would I have to do then? Well, I'd have to go up 3, and then to the left 4. Or you could think of it this way. Instead of looking at the line, you can say, well, if I go down right, I have to do the opposite in order to keep it positive, so you'd be up left. Okay, let's look at number 9. Number 9 is a fun one. I'm going to change colors to pink. At first glance, it looks like there's nowhere to start, but there is, because technically there's a plus 0. So you start at the origin. And then from here, remember there's an understood 1. So since it's positive, that means I'm up righteous. So I'm going to go up 1 to the right 2. 1, 2. Up 1 to the right 2. Up 1 to the right 2. Now, once again, to keep my line, down 1 to the left 2. Down 1 to the left 2. Or, like I said earlier, if you wanted to think of it this way, since I went upright for positive, that means for my left directions, I would have to do the opposite. I'd have to go down and left. And you can see, down and left. So it's whatever, however you want to look at it. Now, number 10, I think, is a great problem. It's a fun problem. It's a problem normally you're going to see in college. And that's because it is not in slope-intercept form. In order to use slope-intercept form, which is y equals mx plus b, y must be isolated. So I'm going to highlight that. And how can we isolate our y? Which term would have to leave first? Well, it's always a term that we described in class as our friend, because they're on the same side as y, but they're not connected. This guy right here we said was his family, because it's like stuck to him, okay? So 3x leaves first. Instead of positive 3x, it's going to be negative 3x, because when you change sides, you change signs. So then you're going to have 4y equals, now to keep it in slope-intercept form, you need to keep the x first. So negative 3x, and this 8 was originally positive, so it stays positive. Now what do? Because you still want the y by itself, you have to divide by 4. And you divide 4 to every single term. So you have y equals, and here I don't ever put this in decimal form, I keep it as a fraction. And also, I reduce my fraction, but this fraction cannot be reduced. And 8 divided by 4 is 2. So that means down here I'm going to start at 2 on my y. And this is a negative slope, so that means I am downright rude. So down 3, 1, 2, 3, to the right 4. 1, 2, 3, 4. Or you could have gone up 3, 1, 2, 3, to the left 4. However you want to think about it. But like I said, do the downright and upright first. That's going to save you a lot of headache than trying to remember your lefts and all that. Okay? The next one, do green. And it's number 11, which is negative x plus 2y equals 6. Once again, I can't just graph it because it's not in slope-intercept form. So I'm going to highlight y. My x needs to leave first because it's the friends. So I add x, because when you change sides, you change signs. So 2y equals, remember to write your x first. Since it's positive x, I just put x, because we don't ever start off a numerical sentence saying positive x. And this is a positive 6, so plus 6. Then I just divide everything by 2. So y equals x over 2 plus 3. Once again, remember, there's an understood 1 as a coefficient in front of x. So I need to start at 3. 1, 2, 3. And this is a positive slope, and positive people are up righteous. So I go up 1 to the right 2. Up 1 to the right 2. Or I could do the complete opposite in order to keep it positive, and that is instead of going upright, I would go down left. So down 1, left 2. Down 1, left 2. Down 1, left 2. So up righteous and downright rude. Remember that. And then number 12, last but not least. Let me go ahead and erase. And if you want, I tell you what, you can pause the video and try it. And then just press play, and I'm going to keep on working it. But it's up to you. Okay, so here's my problem. Once again, I need to go ahead and highlight my variable. So I need to move over my 5x. Negative 5y equals negative 5x plus 10. Divide everything by negative 5. Then I'm going to simplify. So y equals, this right here would just give me 1x, or 1 over 1x if you want to think about it, because you got to have a fraction in order to jump for your slope. And 10 divided by negative 5 is a negative 2, so I just write minus 2. So I would start at negative 2, and it's a positive slope, so it's up righteous. So up 1, right 1. Up 1, right 1. keep on going, or you could do the complete opposite to keep it positive, which is down and left. Okay? And that is what we covered this week in Algebra 1. We do have a word problem that we did, but I'll show the word problems in our next video. All right, thank you so much for watching, and if you have any questions, you can come see me before school or at lunch.